Test 1, 2, 3. Test 1, 2, 3. All right. Then let's just check quickly. That works. And I can hear myself fantastic. Shouldn't mute myself. All right. So hello everyone and welcome back to another episode and the new year 2021 and with my first live stream this year. So what I want to do today and actually in the next couple of months or weeks is I want to finish up the CS50 introduction into artificial intelligence for Python, and I have to mute myself on the stream itself. So, and the idea now is, or what happens if you go to, and this can do everyone, if you are interested, you can go to edX.org, and here, let everything work, the bitrate is okay, looks good, yeah, fantastic. You will see that there are a lot of courses and they are for free. And one of them is the CS Introduction to Artificial Intelligence. And I started with that, so they have a fantastic introduction from the Harvard University. They give you information, Facebook pages, YouTube content, and so on and so forth. And what I did is I already watched the first episode here with the lecture, notes. You can check out the source code, subtitles, transcript, and so on and so forth. And my goal for today, or at least for the next couple of days maybe, I don't know how long we will take, is to implement the first project here. So this is degrees. Write a program that determines how many degrees of separation apart two actors are. So I already downloaded everything here. So you can see if I open up PyCharm, and yes, unfortunately it is Python in that case, but hopefully we can create something with flutters around that. So I don't want to abandon Flutter or anything. It's just because the course is in Python. And for me, actually, it is interesting because I have never worked with AI before. And I just hear a lot about their potential, and I know already about the potential of AI. So the idea of mine is to learn a bit more, understanding the topic, going deeper into it, and then at the end, solve it. So what did I, maybe just a small recap what I heard in the first lesson, and I highly recommend you, if you want to participate also in this CS50 degree, just check out the video from CS50 on edX, and then we have the possibility to check out all the different parts here. And if we take a look into the notes, you will see that they are really, really good. They really explain everything in detail. And hopefully the internet connection is good enough. Yeah, looks good. So, and you will see that there are different lectures. The search is the first one where we are working at the moment on. And you can see the whole thing. And the idea is that we search the perfect or the optimized solution for a problem. And the problem could be anything from puzzles to mazes to things just where we don't know yet the complete solution to it. So if you have something like this and you want to arrange the numbers in the right way, you will have some possibilities. And for that, you will have to learn some names like agent, state, initial state. So the first state that something can be in. You have different actions that you can take, like moving something to the right, you're moving something down, and so on and so forth. And as you see, what they did, and I really appreciate that, is they also wrote like functions that you can execute, like actions from S. And this is very interesting because this actions from S returns a state after you have executed something. So you get all the actions that you can put on a state. So if we go back to this here and take this as a state, one action would be to move the 12 down, and another action would be to move that 15 to the right. And with that, you will get a list of different actions that you can put onto such a solution. Then you have the transition model. And as you see, we have the function from results, which receives S which is a state, and an action. So we have a state and we do something on that. So moving to the right, moving to the left, and we receive as a result a new state of it. So I hear right now that I received, I think, oh no, I got online. All right. So then we have the state space, the set of all states reachable. Hey Debug, nice to see you. So the set of all states reachable from the initial state, exactly. So we have a goal test. That means we have to check if our goal state that we want to achieve is actually the state. And we have the path cost. So what will cost an action at the end? So there are some solutions how you can find that. We always search for the optimal solution. So if we go, for example, into a maze, we want to find the best way for that. And what I really like about that whole course is how detailed it is. So you can see we have the first search, so DFS, which will go in just a very easy telling is that it will search a path and will go it to the completely to the bottom to it. And on the other hand, we have the breadth first search, which will always take both parts of the way and will just check that and compare them and search for the best way. Both of them don't necessarily return the optimal path, but it could be in that path inside. Then we have the greedy best first search. What happens here is that you take a heuristic and you can calculate that. In that case, it is mainly the Manhattan distance. What this says is if you have like a maze like here and you are on this point, you can calculate the path to it, not in the hypothesis like usually. So we wouldn't say from C to B, but we say we go up as many fields as possible and to the B. And with that, we have on these breakpoints, so when we have to decide if we want to go right or left, we can calculate these heuristics and check which path we want to go. And the other thing that we learned, or that I learned, was that you can take this heuristic with the A star search and add also the costs for each turn. So if you want to go to the right, the costs are at least one. And with that, you can define which way is the best. So at the end, we had also min max and so on and so forth. But I think for the first solution that we have, the degrees, the search will do. So let's read the task. I'm not confident that I will solve that today. So if you search for solving of all these, I cannot help you. It's really a learning session for me too. So we want to go through all these parts. So maybe you also have some ideas at the end. So how we get help, we can ask questions on ad and we can ask questions on the CS50 various channels. Exactly. So what is the idea? According to the 6 degrees of Kevin Bacon game, anyone in Hollywood film studios or industry can be connected to Kevin Bacon within 6 steps, where each step consists of finding a film that 2 actors both starred in. In this problem, we are interested in finding the shortest path between any 2 actors by choosing a sequence of movies that connects them. For example, the shortest path between Jennifer Lawrence and Tom Hanks is 2. Jennifer Lawrence is connected to Kevin Bacon by both starring in X-Men, and Kevin Bacon is connected to Tom Hanks by both starring in Apollo 13. We can frame this as a search problem. Our states are people, our actions are movies, which take us from one actor to another. It's true that a movie could take us to multiple different actors, but that's okay for this problem. Our initial state and goal state are defined by the 2 people we are trying to connect. By using breadth first search, we can find the shortest path from one actor to another. Okay, so the idea is to use breadth first search. Getting started, download the distribution. As I said, I did that already, so you will find this inside of it. We have a folder called large and a folder called small. And we have a degrees pi and a util pi. And what I do, I'm working currently on Python version 3.9, and I also already installed everything so that we can directly work, hopefully. Let's check. Oh, still taking the wrong Python version. Interesting. Let me check. Yeah, sure. Because, yeah, okay, got it. So there the problems start already because I'm not that familiar with Python, but I installed it under the system variable of Python free. And with that, we have the access to it. So here and now Python free, and here we get the newest version for it. This is the professional version in that case, but you can work with the community version too, as long as you don't do any business solutions with that. What I did is just the usual thing with installing the Dart1 plugin. So that's the reason why it could look a little bit different to yours. I think everything else should be the same. Let's check, but yeah, the one dark theme is the only thing that I installed yet. Let's see if we need more. Maybe we can also add you with Code With Me, then you can work with me together. Okay, but now let's understanding the things. So as I said, we have the folder with the 3 different CSVs. So it's a comma separated file. I don't know what the F is for actually. But if we check inside, we can see that every parameter is separated by a comma. And so we have an ID, a title, and a year. ID, title, year. And you can see it is built up like a table at the end. So it's the same thing as for people. So these are our actors, the movies are our movies, and stars are the connection points. So we have an M to N connection between those. So we have a person ID and a movie ID. I guess if I'm searching for 102 in people, yes, we find the Kevin Bacon. And he starred in the movie 10-42-57. So 10-42-57. So A Few Good Men. So hopefully that is correct. So, and let's read what happens here. So the distribution code contains the 2 sets. One is large, one is small. Okay. Same structure, but small is much smaller. Yes. So we see also that it comes from the IMDb database, so there should be a lot of films at the end. So if you don't know IMDb, they allow you to create API calls through their database to receive some information about actors and movies and so on and so forth. And you can register and vote also for movies and give them stars and ratings. So I know that there are a lot of people interested in something like that. They also have a name and a birth year. Does the people have a birth year? Okay, yeah, sure. Okay, what do we have else? Then stars, the relationship between people and movies, that's correct. So this is what we tested, yep, and A Few Good Men, so that is correct. Next, take a look at degrees pi. At the top, several data structures are defined to store information from the CSV files. The names, the dictionary is a way to look up person by their name. It maps names to a set of corresponding IDs because it's possible that multiple actors have the same name. The people dictionary maps each person's ID to another dictionary with values for the person's name, birth, and year, and a set of all movies they have starred in. And the movies dictionary maps each movie's ID to another dictionary with values for that movie's title, release year, and a set of all the movie's stars. The load data function loads data from the CSV. Okay. Hey Minu, nice to see you. Hope you are well. So let's have a look. So this is the degrees.py from util. So there's an import that we currently don't use. We have maps names, a set of a corresponding person ID. So I guess this is a map. Can we verify that somehow in Python? Yeah, I just hope so. Maps person IDs to a dictionary of name, birth, movies. Okay. Maps movie IDs to a dictionary of title, year, and stars. All right. Then we have load data from CSV file into memory. So how do we do that? We open the file dictionary. So this is coming into from somewhere, from here, I guess. So this is an arg value, okay. And then we receive the people.csv encoding UTF-8, okay. Reader, we have a dict reader. And for each row in the reader, we create this people map. Or is it an object in that case? No, I think it's just a dictionary, like a JSON in that case. So we have name, row, birth, and movies with a set. And I guess this set is just a creation of a type. Yeah. So if row name lower, not in names, name row lower. Is it a parsing of the JSON? Could be. Names, row names lower at. Okay. With open load movie, load people. So people is getting overwritten. That means it uses this map at the end to create a dict. And I think this dictionary is like, at the end, what the result will be is something like we have something like this, and inside of that we have another part of that with name, I don't know, max, birth, 1923, and so on and so forth. So we have like a JavaScript object inside. I guess this is what happens. So this is why this looks such weirdly. And row ID means that it will take the ID that is inside of the people CSV. So if we take a look here, it will take this ID and will pass that in the map more or less. So we have always, each ID is absolutely unique here. Okay. And what happens here? Names, row name. Names is another, yep. Names to a set of corresponding persons' IDs. So we have a name in lowercase and we pass inside an object with a row ID. But here we do override it and here we edit. Okay. Then we do the same thing for movies. Good. Just curious what this set does at the end. And then we have open for the stars, where we have also the reader and we try to connect. As far as I understand, we have the CSV, right? We read the CSV and this tool, whatever we received from the CS50 team, they already do that to read all these things into a dictionary. So I guess at the end, we just get the maps here that we can use. It could be that it's better for the future, but at the moment it is like that. So I guess this is not our task, right? So our task later will be that we just change one method or something. So, but let's read further. The main function, exactly. So we have the CSV files into these data structures. The main function in this program first loads data into memory. The dictionary from which the data is loaded can be specified by the command line argument. Then the function prompts the user to type in two names. The person ID for name function retrieves the ID for any person and handles prompting the user to clarify in the event that multiple people have the same name. The function that calls the shortest path function to compute the shortest path between two people and prints out the path. So the shortest path function, however, is left unimplemented. That's where you come in. So this is our task actually. If we take a look into the main, we can see, okay, usage Python degrees pi dictionary, okay, directory, blah, blah, blah. We get an argument somewhere from. If length of that is 2, else large, okay. Then we print loading the data and then we say data loaded. This is the part that we checked right now. And then we have source, person ID for name input. Okay, here we can search for a name. So that's that. And the other thing is the target. So, and then comes the method shortest path. And if path is none, print not connected. Else we have this. Degrees, length, print something, okay. And at the end, we come to our method that we have to do. Returns the shortest list of movies pairs that connect the source to the target. If no possible path, returns none. Okay, so that's what we want to do. Person ID for name returns the IMDb ID for a person's name, resolving ambiguous if needed. Okay, neighbors for person returns movie ID pairs for people who start with a given person. Good. So that's the idea. Let's see how far we come. I hope the screen and everything is good to read. If not, please let me know. And we can check more. So specification. An automated tool assists the staff in enforcing the constraints in the below specification. Your submission will fail if any of these are not handled properly. If you import modules other than that explicitly allowed, or if you modify functions other than as permitted. Okay, so this is just if we submit the things, because if you check, we have also the CS50, I think the name is, here it is. We also submit these things at the end, or I submit the things to CS50 because I want to get the certification, but it seems that the internet connection is very slow today. Let me check quickly if maybe I can get some cables here up and running. So that looks good. Let's turn that off and hope that everything still works. CS50. Okay, just a second. Hopefully we will be back online in a sec. Here we are. So as you see, we have a different submission. The quiz I already did. If you are interested, we can do that in the future together. And what you can see is that we can view our submissions that we have done so far. And what's also interesting is that everything from this course is going to GitHub, and you can see exactly here what I have done at the end. So you will find that repository me50, and there is my name in it. And that's pretty cool, I think. But yeah, I just want to get some time before we start with the function, I think. So complete the implementation of the shortest path function, such that it returns the shortest path from the ID person with ID source to the person with the ID target. Assuming there is a path from the source to the target, your function should return a list, where each list item is the next movie ID person ID pair in the path from the source to the target. Each pair should be a tuple of 2 ints. For example, if the return value of short path were 1 to 2 and 3 to 4, that would mean that the source start in movie 1 with person 2 start in movie 3 with person 4, and person 4 is the target. Movie 1 with person 2, that is this part. Movie 1 with person 2. Person 2 start in movie 3. Okay, so somewhere in behind we wouldn't see that. In movie 3 with person 4, and this is the result, and person 4 is the target. So the quickest path is 2 in that case, and yeah. If there are multiple paths of minimum length from the source to the target, your function can return any of them. Have you tried Algo Expert? No. What is Algo Expert? Ace the technical interviews. Okay. Looks quite interesting. So it's like preparing for big companies and how you get there starting to with everything. No, I haven't tried that yet. Is there a reason? It looks like... Ooh, it looks expensive. But if it's true that there is Google and everything behind, maybe it's worth it. Hard to say. The problem is I'm anyway contractor, so I usually don't go with that stuff. But interesting. Okay, so if there are multiple paths of minimum length from the source to the target, your function can return any of them. If there are multiple paths of minimum length from the source to the target, okay. If there is no possible path between two actors, your function should return none. If you may call the neighbors for person function, which accepts a person's ID as input and returns a set of movie ID and person ID pairs. Neighbors for person. For all people who start in a movie with a given person. You should not modify anything else in the file other than the shortest path function, though you may write additional functions and or import other Python standard library modules. While the implementation of search in lecture checks for a goal when a node is popped off the frontier, you can improve the efficiency of your search by checking for a goal as nodes are added to the frontier. If you detect a goal node, no need to add it to the frontier. You can simply return the solution immediately. You're welcome to borrow and adapt any code from the lecture examples. We have already provided you with a file utilpy that contains the lecture implementation for node, stack frontier, queue frontier, which you are welcome to use and modify if you like. Okay, fantastic. Good, and then there is how we can submit and everything. So, let's see how we get better here. So if I take a look into utils, we can see there is a node. This is containing, a node always contains the state, the parent state, so where did we come from, then which action lead to this current state, so that we have the possibility to roll back more or less. So we have the possibility to find the way that we have gone already. Then we have a so-called frontier, and the frontier is interesting. If I have that right in mind, we have the possibility to add nodes. So like here, we have the I think with the self frontier, it is like inside of this class frontier, we have now this variable frontier, which is a list at the end where we add new nodes. And then we have contain state, self state, and it returns anything. What is any? Any is just one, okay. Node state equals state for node in self frontier. What did I read right now? So node state equals to state for node in self frontier. If the state that we want to add to the frontier is already existent. Is this used somewhere? No. Okay, then we have empty, where we return the length of the frontier. So if the frontier is empty, we have this question here. And then we have remove, where we remove one node from the frontier and do it somewhere else. Yeah, I actually, in my university, they didn't have an AI class, so now I have to learn it myself. I think that is even harder. So here we have remove now something, because the queue frontier regarding to the stack frontier, you can imagine you have multiple nodes. So maybe we have a screenshot from that somewhere in the nodes. I think I had that open somewhere. So let's check the edX again. So resume to the last course. Let's check the nodes. Or better the slides, I think. By the way, the CS50 course is completely for free. So if you want to, you can directly join. No problem at all. So knowledge, this is something else. Uncertainty, optimization, this is just the stuff that we will learn in that course. How we can solve that, search problems, agent state, blah, blah, initial state, actions, transition model, pop, pop, pop. So let's assume we have something like this, right? Where we have all these blue dots are nodes that we have created. Yes, debug, it's completely free. It's amazing. And from Harvard, which is something that I always want to point out because, yeah, it's a very large university, right? So can I see that? Wait, if I go to private browsing, let's search for AI CS50. Maybe I should send you the link here, this one. And I think that is, if you want to have the certificate, you have to pay for it. But if you do it for the free path for it, then you don't have to pay. So this guy is it actually that I do. So let's see if I can share it with you. Twitch TV. Oh wait, I can actually, no. Twitch. Ah. So welcome to the new year. Nothing has changed to the old year. I'm not logged in. Let me see if I can change something. Yep, a lecture. Ah. Twitch TV. Let's go to the channel quickly. Send quickly something in the chat and put that here. Fantastic. So, okay, but all of these different things are nodes, and every node contains like a branch, right? Oh, I hear myself. That's not good. Silence. So every node goes somewhere else, and you have now different options. You could go here or here or here. And the idea is now that we take one of the nodes, we check if this node is our goal state that we want to achieve. If not, then we take the next step. And this is if you take the DFS, so deep first search. We go the whole tree in one direction first. And then we take the last node where we have made a distinction, and then we take this information. This happens with a stack, because if you think about it, you put a node on top, and then you take it away, and you take the next node on top of it. I hope I explained that correctly, but I hope the best. So let's see if we find somewhere search in a state solution, a sequence of actions that lead from one. Yep, optimal solution. So here, find a path from A to E. So the idea is we have A, we go to B, we repeat, start with a frontier that contains the initial state. So that will be the first thing that we receive. And then we repeat, if the frontier is empty, then no solution. Remove a node from the frontier. So we remove A from the frontier. If the node contains goal state, return the solution. So if A would be E, then we would return the solution and we would be done. Else we expand node, add resulting nodes to the frontier. So we expand the node, that would be, I think we go one further to B, and then we add the resulting nodes to the frontier. Here's also an example. So first we start with that. We remove a node from the frontier. And we get B inside. And then we move to B and do the same again. So we remove it again, we expand it again, go to C, and so forth. That image with path cost. I think with the DFS and so on, you don't really have a path cost, but I think if you mean this one, yeah, could be. So you have one step that you will do in each direction, and DFS would say, okay, you go there, then there, then there, then there, then you will go there, then we will go there, 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 and so on and so forth. While on BFS, which we will do most likely, you have a queue. That means you take A, D, and H into account, and then you search just one of them. And then you add B, for example, but you have still D and H inside. So you will decide to go to D first and check that. And then you will go to H to check that, even though that A and M is connected. Whew, that was a lot of text, sorry. But I think in that description here, if we search a little bit, if scroll a little bit down, we also see the solution here. So I guess this is the BFS part here. Just let me quickly check. Start with the frontier. B, go to B, B and C and D. Yeah, so you can see we add from B, C and D. And now because we remove C, we still have D inside, and we put E inside back. So this is still the DFS. What could go wrong? Okay, so one thing that could go wrong is that we go back and forth. Can I share it? Well, I actually don't. I can send the link, I guess, but probably you will have to log into the CS50 course. Let's see. All right, so what could go wrong? Of course, if you have this double path, you have to make sure that you don't go back again to the old nodes. And I think that is what happens here in this part with the remove, raise empty frontier, node, self, frontier -1. Do we have the old nodes, contains state, probably this one. Nah, couldn't be. Cannot be. Okay, so start with a frontier that contains the initial state. Start with an empty explored set. So we need a set for explored. Page 33. 1, 2, 3. Yeah, but this is BFS, right? 1, 2, no, 1, 2, huh? Yeah, but we don't really have a path cost in our case, right? Because every path cost is 1, actually. Because if I go from one movie to another, I don't really have a cost for the path, right? At least this is my understanding so far. Okay, but what we have here is the revised approach that we can use in order to develop the stuff. So start with a frontier that contains the initial state. That is the path cost. Path cost must be least. I think I understand what you mean, but actually I think it will not really solve our problem in any case, right? So what you are talking about is then stuff like blah, blah, blah. Let me go further. I think on the bottom part you will find that deep first search. Then we will find the BFS somewhere. Yep, that's here. And after that we are coming to the greedy first search, and I think there is the first time when the path cost comes into play. More text, heuristic functions, this stuff, and here comes the cost or more. No, this was the heuristic first, so it's just the A star search that currently has that with the amount of values that you add. So like the 1, 2, 3, so this is the cost that it takes to go somewhere. Where was the explanation for that? Here. So GN cost for the reach node, I would guess. So search algorithm that expands node with the lowest value of GN and HN. But the problem with our solution is that, as far as I read, we should use the BFS, right? If I had that in mind. Or was that the function handled properly? Checking implementation, stack frontier, queue frontier. But yeah, let's just first start. And where was that? I searched that somewhere. So yeah, here. By using briefer, we can find the shortest path from one actor to another. So I guess the solution here is telling us that we should use the breadth first search. 35. Search problems. Yeah. What was it? 58, right? We revised approach. Yep. So let's read that. Start with that contains the initial state. So let's see where our frontier is. So we initialize the frontier with an empty list, and we have to add directly the initial state. So let us check how would that work at the moment. So how can I execute that stuff? I think while executing Python 3 and saying degrees pi. No. Yeah, go away. And I think we have to pass in the information that we want to use the small one. So small, maybe? Yeah. So let's search for a name. I think that is the first person that we want. So like Tom Cruise. And the second person would be Tom Hanks. So, and now we run into our unimplemented error here. Execute the main, and we are coming here, and this crashes at the moment. So in order to do that, I think we can print here, and we can print the source, and we can print the target just to see what happens. And maybe we can even debug the whole thing. And I think this is actually up. Where is our main function? I guess if I say run on this one, yeah, this works, but we want to do it on small, so I edit this one. Can I give that a name? Yeah. It also includes path cost function. Yes, I know, but okay, let's say it this way. I don't know better. So at the moment, if you have ideas, we can try that, but one step after another. I think Deepak said that yesterday, very nice. Just do one small step after another, and then we are coming further. So person not found was not a good idea, so yep. Let's see, Tom Hanks, and the other one was Tom Cruise. Not implemented, but we get some information. We get 158 and 129. So these are just the, how do we call it? The IDs. So returns the shortest list. Okay. So person ID for name returns the IMDb ID for person's name, resolving ambitious if as needed. Okay, there. Okay, neighbors for person returns movie ID and person's ID pairs for people who start with a given person. Okay, so we could use this method to receive the way from what is actually our node? I think we have to also create nodes. Another thing that we can take a look into is how they solve the CS50 stuff. So if I, this is just navigating here. I think I have to go back to edX once more. Here we have also source code, and I want to take a look into that. So here are different mazes, and I want to open up that one. So we have a node which has these parts, some maze that is created from the file. And what happens here is what exactly we have to print, solvings, okay, queue, stack frontier. We have all of that already. Init with open, contents, okay. So solve finds a solution to maze if one exists. So keep track of number of states explored. So this is what we want to keep track of. Then we have start. This is just creation of a node with self start. Oh, is it also buffering for me? No, it's all fine for me, I think. But maybe I already used, sorry, Minu. Maybe I use too much internet if I everywhere running the video. I think that's not a good option. Maybe it's now better, hopefully. Okay, but interesting enough, we have to create the first node. So initialize the frontier and we add the start part. So I just use that as split right. So we always can use that as a reference. So, and now let's see what we can do in our utils. The utils we can use. So where is our method? Here. So the start would be our first node that we create. So we create our first start, which is our source, I guess. What is the state actually in our case? The initial state would be we don't have a parent, we don't have an action, but we have an actor. And our different states are different actors, and the action is the movies, right? So what we want to do is using the node with the state, and this would be our source. And I think the parent is exactly the same because we said that this is always none in the beginning. We don't need that, I guess. Too much then we create our frontier, which we can, which we should use the Q frontier, I guess, because the Q frontier is for BFS, so breadth first search. And now with that in mind, we can use these both. And as you see, it is taking all the properties from the stack frontier while it is getting extended by it. And now here we can add to the frontier our first state. So initialize an empty explored set. Okay, so this explored set is therefore there that we don't go back to one that already existed. So let's do, I think we can exactly do the same thing, right? Because we are not in a class, I cannot do that, I guess. So we don't have to print these anymore. We have this explored set. Okay, and actually I think, what do we see here? If nothing left in the frontier, then no path. Okay, so this is the easiest way, right? So we just raise an exception, are done. Choose a node from the frontier, so we remove, and we can see that the node is getting returned from that. Yeah, fantastic. Okay, self num explored. We increase the number of explored nodes. If node is the goal, then we have a solution. Okay, so node state is equal to self goal. Self goal, that would be in our case the target, right? Actions cells while node parent is not none. Node parent is not none. We actions append, we get the cells. Actions reverse, cells reverse, and this is the solution. Mark node as explored. This is adding it to the explored set that we have here, and it can only contains once the things, right? So at least this is what I think about a set. Add neighbors to frontier. Action state in self neighbors node state. If not, frontier contains state, and state is not self-explored. The child is the node with the parent node and the action, and it's getting added to the frontier. All right. So I guess it's not that complicated at the end. It's just that we have to learn how exactly this works. So we keep looping until we find a solution. That's easy. I think if we find a frontier that is empty, we can return that there is no solution if we start with that. Choose a node from the frontier. Okay, we already added one node to the frontier, the starting node, right? And after that, mark node as explored, and at the end we just add another one. Okay, good. Let's see if I can remember everything that I want to. So while true, and now we do whatever we want. And the first thing that we have to do is we want to say if the frontier is empty, empty true. It is already a boolean, of course. Then we can raise an exception. In our case, if there is no path, I think we just return 0, right? So what is the solution? Let's read once more. Source and shortest path is this. How to submit. For example, if the return value of shortest path were 1, 2, and 3, 4, that would mean blah. If there is no possible path between two actors, your function should return none. Okay, so if the frontier is empty, actually we can return none. So we don't have to raise or anything. But we have now a frontier, or better, So if our state would be a solution, then we have to do something. We have to return the quickest path. So if the start, no, not the start. We first have to get the node, right? Node equals frontier dot remove. So we get the first node at the end. And inside of here, we can now check if the node is equal to node.target. No, the target. If the node is equal to the target, then we are happy, right? So happy, solved. The question is just, how do we do that again? So if we know that the node is the target, we do that. And the alternative is that we say, okay, if it is not the target, node is not the target, what we will have to do is we have to add the neighbors to the frontier. So the node frontier remove. If node is target, we have it solved. If not, we do something with it. Does the stream still running? It looks good, I guess. Yeah. Maybe I can just quickly check something. Yeah, okay. All right, so that's that. But I think we had one step in between that I forgot. So, this explored part was missing. And if we take one, we have to also say that the num explored, or in our case just explored, has to be increasing by 1. If node state self goal, node.state, important, sure. Because node is of course an object. Can I see that somewhere, that this is from that type? I think I can do something like this, I guess, right? So now this is a bit more typed. So dot remove is for sure, but here we have the node.state. This is getting yellowish. No, that's fine. Same thing for that. So before we now start to make the happy solved, let's first do the self.explored. We don't have explored.add. Wait a second, why we have num explored and normally explored? Keep track of the number states explored. I forgot about that. All right, so we should add that. And here we receive the num explored by 1. And the explored itself receives the node.state. So with that, we make sure that we never go back to an old node. And then this part is a bit different. So for action state in self neighbors node state. This neighbors is that function that we have underneath, I guess. So this is the neighbors for person. But here it returns an action and a state. We only receive neighbors. In self neighbors node state. Person ID for that returns the IMDb person's name, resolving ambitious as needed. neighbors for person returns the movie ID and the person ID pairs for people who start with a given person. If I take a look into that, what do we get? We get candidates. What is the return? Is a result, and this is a list. Result append action. RC. Okay. What do we return? We return neighbors. And what we can do is we can just try that. So what happens if I'm adding here something into? So let's say, let's comment that out for now. This is also not mandatory at the moment. And we just say, I guess we should, let me see. So we get a person ID and it returns a movie ID, which is our state, no, our action, and a person ID, which is our state. So that's fine. Okay. So if this is really what we return, then this is correct. Then everything is fine. Okay, I just got confused by that. That's fine. So if we now say, don't even know if we need that, but I guess, where's our short path? Here. So inside of here, we can do that with that. I think we don't even need that if, but what we can do is we can say we have an action and a state in the neighbors for person where we add the node state. I think that is exactly the same. So, and if not, frontier contains the state. If the current state is not part of the frontier yet and the state is not in explored, then we create the state as a new child. It is not in the frontier yet because we don't want to have it duplicated inside, and it is not in explored, so we don't find it again. Okay, makes sense. Yeah. And the state is not in explored. And with that we can create a new node with the state, which is exactly the same. So this is the person ID with the parent node, which is the node where we are at the moment, and the action that led to this way, so the movie in our case. And then at the end we say frontier.addChild. Okay, and with that we have created a new node. We go again to the while loop and work our way through. So this makes sense. This one needs to change a little bit. So if we find the right one, we want to return the path to it. And we always get the action and the state. So we have actions that lead to something, cells that lead to something. And if you are confused why I'm working directly one versus one from the solution that they have here, that's just because it's the first time. So if I work now multiple times on that, I think I will get better and better with that. And I think the second solution will be also not that easy. So if you take a look into this degrees program, there is also more than just one, where is it? Here. There's more than one project. There's also the tic-tac-toe solution where you will work with the other part. So this is just something that I will learn more and more by just using it actually. So while node.parent is not none. I understand. So we get the action and the cells. Why cells? If the node state is the target. So we know now that this is the real goal that we want to achieve. Okay, cells is just a name. So in our case, it's movies, I guess. The actions, wait, give me a second, I have to think. So the actions are the movies. So this needs to be our persons. So if the node parent is not none, we go through the whole list. So we have now our path, and now we reconstruct our path more or less. So we say, okay, as long as there are things, we append new actions to it from the node action. So we traverse the tree upwards more or less. So go here, and we have this now the persons that we can append with the node state. Node equals node.parent. Okay, so we change now the node, and then the while loop goes further until node.parent is empty. Good. The next step is that here we reverse them, and the thing is we want to find not the way from the solution to the goal, to the start. We want to find the start to the goal, and I think that's why we reverse them. Persons.reverse, and then we have the solution. Okay, I don't know. Actions persons. Kind of this. Just a question, it's not. Okay. With that we can remove this part. And what I can say is that this one will return, I don't know if this is a Python way to return stuff, but on my feeling, if we return actions and persons, this looks like two lists. And let's try that. Let's see what the result is from it. So we search again for Tom Cruise to Tom Hanks. 2 degrees of separation, trace back. So we can only concatenate list, not tuple to list. What's that? Ah, wait. What should the shortest path return? If the return type of shortest path were a list with 2 tuples, that would mean that the source start in 1, 2. Okay, maybe I should print the solution first before I return it. So we receive that. What happens if I get actions and persons? Tom Hanks and Tom Cruise. Oh. So we get 2 lists. One is with actions and one is with persons. Yeah, it's exactly what I wanted to see, but that's not what we want, right? If the return value were a list of 1, 2, 3, 4, turn a list where each list item is the next movie ID person ID pair in the path from the source. So what we actually want is action 1 and person 1 and so on and so forth. Okay, how can we do that? We can I don't know, they should be the same way, right? So for action in actions. And now we can say something, okay. How do we get an counter for that? So for loop Python. X in fruits, print X. Okay. The issue is that I would need an integer or something. Is that everything? While loop if. Ah, wait, I can maybe do something like that. So action and person in action or persons. Oh, that looks weird, but let's see if it works. So we have to create a list first. So list, or solution is a list. And what we want is in this solution list, we append action person. Remove argument, no. Like so, probably. And then we want to return solution. Very happy that you see it that way, debug. I'm always just talking with my head and hope that everything works out. But I know exactly what you mean. Key error. Person, people, path. Okay, he tries now to access the second person with for E in range of degree. I need to do something like that. Okay, fantastic. So that here is for E in range of actions. And then we can say something like this and say actions I and persons I. Unexpected argument, and what's the problem? Got list instead. Where's the main function? I think I saw that somewhere. So for E in range of degrees, and degrees is the length of path. Okay, so that is the reason. We have to go down, and here at this point we have to say length of actions. So, and this one is an unexpected argument. Can we not? Something like that. Ah, look at that. I think that is what we wanted to have. Ooh. Okay, so let's see. That means we have now the solution. We got this. So let's read it one more time just that I understand. So we want to search for the shortest path, and we want to use the BFS, so breadth first search. For that we will need a queue frontier. A queue frontier exists out several methods and itself is just a list of different nodes. So this frontier actually is a list of different nodes. I think we can remove this. I am not allowed to change that, I guess, so I'll keep it. So if we add a new node to the whole thing, we put it inside of the list of nodes. We can check the frontier itself if it contains a different state or if it contains a certain state. We have empty, where we check if the frontier is empty, and we can remove a node from the frontier. So what happens is we take the node from self frontier -1. We say that the self frontier, we reduce it from the end of the frontier, and then we return the node. And as you see, the only difference between a stack and the queue frontier is that the queue frontier changes the remove function, while the stack frontier removes it from the end of the list. The queue frontier takes it from the beginning of the list. Okay. By the way, we can also recreate the whole thing by Dart. I think sooner or later I will try that just to see how it works there and if it is kind of different. But it should work nearly the same. Okay, so we have the neighbors for person. We receive the information, how they connect, and now we can try that with the large set, I guess. Do we have some persons that you want to search for? What do we have here? So let's search something I know. Sam Neill. Eve Plump. What a fancy name. Let's see. Who is it? Eve Plump is an American actress who portrayed the middle daughter Jen Brady in the sitcom of Brady Bunch. Okay, I absolutely don't know her, but she is my first initial state. And let's search for another one. Who's here? Ernie Hudson. Who are you? Aha. I think I know him. Ernest Lee Hudson is an American actor. He has appeared in dozens of film, television. Yeah, Ghostbusters. All right, of course I know him. Okay, so, and he is my target. Let's see how many we will use to find the perfect way. So it seems to be a 4 path at the end. So 4 degrees of separation to find between these two. And we can see that Eve Plump and Catherine Hughes were in Monsoon. Catherine Hughes and Travis Tobe were in Say You Will. And Travis Tobe was with Dylan Arnold in Disfluency. And Dylan Arnold and Arnie Hudson in Adventure Force 5. Is this a good movie? Sounds interesting. It looks very trashy. Cool. So as you see, I'm not really a movie expert, but actually our solution works, which is quite interesting. Cool. So, and now comes the heavy part, because I want to re-understand everything. So we have this frontier understood, we have the node understood. A node is actually just one of these dots, right? We have the possibility to go back and understand how the parent worked. We understand how the current state is working, and we know which action lead to this transition. Then we have the frontier, we add the first node to it, just that we have something in the frontier, else we would be done immediately. We have a set of nodes that we have already explored that we check on the bottom whenever we want to add a new state. Then we say if the frontier is empty, we return none. Then we have the frontier where we remove one. Important is that the remove function has to return as a node. Whenever I have to rewrite the frontier myself, I have to keep that in mind. Then we have the numbers explored. This is just to get the number, I think, at the end of the whole thing. So there are 4 degrees of separation. And now this part is if we find a solution. So first of all, we get all the actions, all the persons that are involved, while node parent. So if our current node, that is the target node, has a parent, then we append the action and the state of the current node. And then we say that the current node is the parent of the node. With that, we go further in the while loop. Now we append the actions of that node and also the persons of that node. And then we go one level higher. And if there is no parent anymore, then we are finished with the while loop. We reverse the way how we got there. And at the end, we just build our solution that we want to return. If we don't find the target solution, we say we explored another node. And then we go inside of the neighbors for person. So how does this method actually work? Movie IDs, people, person ID, movies. So people is that set that we created up here. And inside of that set, we can search by the person's ID and we get the movies back. Movies is a list of different movies. Neighbors is a set, okay? And in every movie ID, movie IDs, that we get from the person, we check now every person ID that is involved in one of the movies where there is stars. Okay, I got that. Cool. So at the moment, what I understood is that the most important thing to know is what is your state and what is your action. If you understand these two things, you actually can create nearly everything from everything in such a search meta. But this time is interesting because it's not a maze that we solved. It is more an understanding of how we did it. What I would like to know is if I take the same solution like this one, it's now with 4 people, right? And as far as I've understood while I got the presentation from Harvard, I can change that to a stack frontier right away, and everything else should work exactly the same. So if I now search again for this with Eve Plump, it could be that we don't find the optimal way, or that it takes more resources. So let me check if this is true. So the first name is Eve Plump, and the last name is Ernie Hudson. Oh, it takes way longer. The fan is starting. Monitor, where it is, here. So let's see if the CPU is used by Python at the moment. Okay. What is actually used at the moment? That's interesting. Is it the I/O? We don't write, we don't read. That's interesting. Huh. Okay, maybe it cannot. Wait a second. Mistake. Okay, let's try that once more. Yeah, data loaded. Okay, so Eve Plump to Ernie Hudson. So I know you probably can't hear it, but my MacBook is starting to highly work. At least from the fan noises. So let's see what the Twitch chat does. Up. All good here, perfect. Does it not find a solution? Do we get any problems up here? Python 3? No, it takes everything. Here nothing happens. I would guess that there should be somewhere a Python process that starts to take more and more power. this guy here, for example, with 99% of the CPU. Huh. Why is he that low? Yeah, and the problem is now probably that it needs to run through each node that exists. And because of the DFS, it will not always take the different view movies as far as it can go. So it could be that it goes a tree that is really going down the whole tree at the end. And I think that will take a much more power. I just wanted to see how long it will take, but it takes really long time, I guess. So let's change the stack frontier back to a queue frontier, I guess. And I guess we can kill this process and just be happy that it works with that. I think I need the new M1 chip first from Apple before I can do such stuff. So Eve Plump and Ernie Hudson. So it is really a performance issue, or does it work now? Huh. Slowly I get the feeling that I destroyed somewhere something. Let's cancel that once more. And let's try this. Ah, no, this is the small one, of course. So, once more. Oh, I forgot the names. What was it? Eve Hudson and something else. No, I forgot the names. Okay, let's take Bonnie Hunt and... Oops. Nope. I think Eve Hudson and... No. Do you know any famous actors that we should use? So Bonnie Hunt and I don't know, Kim... Ah, Tom Cruise. Okay, here it's just 2 degrees of separation. And if I go now and change that once more, and I take now that as an example, I just want to see if it works in any constellation. So Bonnie Hunt and Tom Cruise, okay. Ah, something with Plump, exactly. I think Eve Plump or something was the name, right? Eve. I cannot search it, it's too large. Oh well, not too important. Tom Cruise. So yeah, I guess that is just not a problem that we would use DFS for. So this is really a BFS problem. Just to keep that in mind for the future. All right. So we added the first one, we explored, we made a while loop. So as long as we have something in the frontier, we go through here. If the frontier is empty, we return none because the task set us so. Then we have frontier remove, where we get our first node that we can work with. We check the number, we did that stuff, fantastic. So, and because that doesn't work, I cancel that now, kill the process. Don't use too much of my resources, it's too much energy. Don't mine bitcoins or anything here, so let's do this. So, and here now, because I solved that issue, or at least I hope I solved that issue, I will go here, and I think there is a submission possibility. You may not have your code in blah blah blah. So, and I have installed this submit 50, I think. So let's check. Submit 50. Yeah. So the following are slug. So how can I? If you have installed execute submit 50 AI project 2020 X degrees. What is X? Where username is your username. Okay. Log into GitHub, authorize CS50. I did that already, I guess. Join course. Let's see if I have done that. Yes. Install Git, we have that. If you have installed execute. Okay, just this. And submit this form. Alright, Deepak, enjoy the rest of your day. Thank you for joining. It was something else, I think, today. Push your work to this, where username is your Git username on a branch AI. Okay, let's try this. Authenticating, GitHub username. Ah, that's how it works. Okay. Okay. Can I set up the submit 50 in a way that it takes SSH? Let's see. Log out of show this help message submitting with via SSH. Push your work via permission denied, public key. This stuff starts again. Okay, so let's check out GitHub and create some private SSH key. On the other hand, what I can also try is, because I think let's see if the password is correct. Nope. Okay, let's check that over here and go. Just give me a second. Have to search for that. Ah, no, that's not it. Ah, yeah, sure. I have 2FA activated, so I have to use SSH in that case. Unlucky. Okay, let's see. Then we do it differently. Up, go back to here. And let's search for the SSH possibility. SSH. New SSH key, and let's call that submit 50 for CS50 degree AI. So now we need an SSH key. Never have done that before. Open up new. Generate. checking for generated. Yeah, we can just check for them because I guess I should have one. So let's see, we go here. And .ssh, and here we have the two of them. This is the public. Have a public SSH. By default, the file name of the public keys are one of the following. Yes, yes, yes. If you don't have an existing public pair. Okay, so open that one. Exactly. Now, if I'm adding that here. Yes, now we have added that one. Exiting this. And let's see how we can do that now. Perfect. Works like a charm. And verifying, preparing. Are you sure you want to submit these files? Yes. To see your results. Ooh. So as I said, I'm really happy with that tar 0 comments style 50. Looks good, but consider adding more comments. To adding more comments, really. Can do that, of course. So if they want to. So in our case, this is the number of explored nodes. Then here we create our first node, our initial state, is it? Then we have using BFS is more efficient. So BFS, let's write it out, broth first search. I think broth. Not sure anymore how to write it, so let's take a look. First, no. This is the submit 50. I have to go back. This is the submission. Here we go. Degrees. Breath first search. Breath. So like breathing. Okay. So breath first search is more efficient. Then we add that. We have here a set of explored nodes. Has nodes. Return none if there is no valid path. Or no valid path, then here we remove the frontier. Remove a node from the frontier. If the node state is the target, so this is the solution. Received a optimal path. Not optimal, I think received a path. Solution, or is it the optimal? I think it's optimal path, or it could be the optimal path. I think there was a thing that it could also find a normal path. So for that we have then a star search and the greedy first search. And then we have the explored nodes. Add explored node to already add the current node to the explored ones. Set up the next node for the process. Neighbor nodes, we got that. Yeah. Okay, so I have all that in mind. We push that again. Authenticate, verifying, preparing. Good. So, and now we can see here. Two commits. That's really cool. That's a really cool solution from that from the university. Looks good. And the util could need more comments. Yeah, okay, but this is like from them, right? Okay, so I just keep it like that. So let's see my submissions. That's that. My courses is this one. Submitting Thursday. What is that? Is 0. Okay, happy days, I guess. Okay. What I would be interested now in is if this is represented in this one. It's like my scorecard for the CS50 degree, which is, by the way, completely for free, and you can just start right away with it. Has been received, but be sure you have submitted your Google form as well. It may take up to 3 weeks for your submission to be graded. Please be patient. Okay, I have time. But interesting, there is somewhere a form to the whole thing. So let's see. Okay, this is my email. That's fine. Max Weber, that's my name. My username is mdweber. I am in Karlsruhe, Germany. Grading in the course is not done automatically. Grading may depending on exactly when in our grading cycle you submit. Take up to 3 weeks. Okay, your grade status may change in the gradebook in the interim. But grades are never final until you receive a score released email from the CS50 bot. The staff cannot entertain requests for expecting under any circumstances. I understand. Have you definitely submitted your code? Let's check. But I think yes. MD Weber. Yeah. Okay. So yes. Does your code implement every feature required by the project specification? Review the specification here. Okay, let's review that. How to get help, background, getting started, understanding, specification. Assuming the path of source target, your function should return a list. In the path from the source to the target, each pair should be a tuple of 2 ints. Yes, that we have. If there are multiple paths of minimum length from the source to the target, your function can return any of them. Okay, so if there is one with the same length, we should be happy with it. If there is no possible path between 2 actors, your function should return none. We do that. You may call the neighbors for person function, which accepts a person's ID as input and returns a set. Okay, we do that. You should not modify anything else in the file other than the shortest path function. We have done that, and that's it. Okay, so I guess this is done. Yes. Comments, if any. No, I think we are happy, so submit. Okay. And I think I got an email right now that the submission has been done. Yep, looks fantastic. All right, so that's the first degrees part. So let's see what the other one is. Maybe we can also solve the other project today. That would be amazing. Node source code project. Tic-tac-toe. So, okay, so this time we want to solve it by min-max. And just maybe a quick overview what min-max is. We have the lecture here. If you play a game like tic-tac-toe or anything that can be solved optimal, or even if you can't solve it optimal, but you have a path that you can go, and you evaluate every path that you have there, then the min-max function comes into play. So you have one player who tries to achieve a number 1, and you have one player who tries to achieve -1. As you see, in our case, the circle is trying to receive -1 as a value of the path, and we as X player want to receive 1 in this case. So in the minimax function, we have two different players. One who is trying to maximize the outcome of X, and one who is trying to minimize the outcome of X. And so in our case, this is X and O. So what do we have? We have players, so which one is at the moment playing. We have actions, what we can do. So we have a field of 9 and we can make crosses everywhere or circles. We have a result, which is the new state after an action has been done on this state. Terminal is if the game is over. And utility, which gives us a value for the different states. So the initial state is empty, and then the player is of an empty. So the player function returns us if we give an empty state inside X, and if we give a state with an X at last with an O. And then we have different, if we put it in actions, we get different states that it can take. So like it could be on top left, it could be in the mid, and so on and so forth. But I don't want to go in too much detail. But what I want to show you is something like this graph. So you can see in this case, the min player is at the moment on the way, and he knows that the next steps, he can take 2 steps in tic-tac-toe. For example, everything else is taken but 2 steps. Then he could take the one where the max player receives 9 points, or where the max player receives 8 points. And now he decides between these two that the max player can take. And so he decides that this node has the value of 8 because it is the lowest value that the max player can receive. And the max player is always searching for the highest score here. So that means if he is on the turn, he can receive 9. So 3 and 5 is obsolete. And if he can receive 8, 2 is obsolete. And the same thing is going on and on and on, and it's getting explained. And the same thing here. So if the max player is on the run, he can decide between these 3 routes. And as soon as he finds one that has the most value for him, and the most value after the min player has played optimal, that means the min player has the chance to play one with 4 value, 8 value, and 5 value. So he knows on this part that the min value player will most likely play for the lowest possible value. And so you decide for the right path. And yeah, there seem to be a lot of possibilities. So you can see that tic-tac-toe has a possibility of 255,000 different states. And that means if you see in chess, it's even more, and so on and so forth. So we cannot work with optimal data. So we have to somehow reduce the things, and there comes the depth limited min-max into play. Yeah, but I don't want to go into much detail. As I said, take your time, just watch the first episode of this CS50 degree, and yeah, it is really amazing. Okay, using min-max, implement an AI to play tic-tac-toe optimally. Let's see when to do it. Ask questions. Okay, download distributions. I didn't do that yet, so let's start with that. Unzip that, and I will take this folder and bring it over to the development folder here. So we can open up that in our PyCharm directly. Development, tic-tac-toe. This window. Yep, we use the same environment. Oh, that's amazing. They really implemented the whole game, I guess. Oh no, it's not implemented yet, everything. Ah, okay. While true event get py quit, okay. clean up. Wait, maybe we are not allowed to change anything here again. So let's first read the text. In the project, run pip 3 install r requirement txt. Okay, this installs a dependency, I guess. There's like pub.get on Dart. Already satisfied. Okay, so we have that already. Can I check that somehow? Pip 3 Python include pygame. Yeah, I guess this is what we have inside. Good. There are two main files in this project, runner and tic-tac-toe-py. Contains all of the logic for playing the game and for making optimal moves. Runner.py has been implemented for you and contains all of the code to run the graphical interface of the game. Once you have completed all the required functions in tic-tac-toe-py, you should be able to run Python runner.py to play against your AI. Oh, cool. Let's open up tic-tac-toe-py to get an understanding for what's provided. First, we've defined three variables, x, o, and empty, to represent possible moves on the board. To get an idea for what's provided. Okay, so let's open up and see. X, o, and empty, okay. Definition, initial state. At the end, every field, and as you can see, this is a two-dimensional array. So we have an array inside of an array, and or better, three arrays inside of an array, and it represents the first line, the second line, and the third line. And all of them are empty because no player has set something. So then we have the players. This is who is the next turns on. We have the actions, results, winner, and all of them that we are talked before. The function initial state returns the starting state of the board. For this problem, we have chosen to represent the board as a list of three lists representing the three rows of the board, where each internal list contains three values that are either x, o, or empty. What follows are functions that we have left up to you to implement. Fantastic. Specification. An automated tool assists the stuff to check. Okay. Complete the implementation of player. Actions, result, winner, and min-max. The player function should take a board state as input and return which player's turn it is, either X or O. In the initial game state, X gets the first move. Subsequently, the players alternate with each additional move. Any return value is acceptable if a terminal board is provided as input. The game is already over. Any return value is acceptable if a terminal board is provided as input. Okay, so the player returns a player. So we receive the board, and I guess the board is just also a list with different lists. So the player receives the current state. So how could we implement that actually? So what we know is that if X is on the way, we should have, we could count the X's and O's and then decide that the one who has more on the board, so if X has more on the board than O is on the move. If we have, yeah, and that's it actually. Could be the easiest way to just count them. Just have to think quickly, but I think so what we could do is for row on or in board, because we have each row, right? We can count now everything inside of it. So how do we count? Does that Python count in list? I don't know. Of a given element of list of a string. Okay, list count element. How does it work? We have a list of strings, list count, and then say green. So we could say row.count O and row.count X. And as a result of that, we have if O and X. Don't really like the naming, but if O is smaller than X, then return X. And if O is equal to X, return O. Else if, I guess. No. Elif? Elif? Elif, okay. So, can I write a test for that? I would love to write some tests for that. For row in board. How does that work in Python? I think we can write a test or not. Python unit test. Don't be silly, getting started with testing in Python. Testing here. Just a basic unit test, please. Super simple. Aha. Okay, so class test string. So let's create a file here called where we are tic-tac-toe.test.py. Class tic-tac-toe test. Isn't it right? No. Yes, unit test case. And we don't need braces. I really have to go into that. So, all right. So now we have here different definitions. Like, for example, we want to test if the player is working correctly. So test player self, and we receive so. Okay. And then we can say assert equal foo upper foo. Okay. Okay. So with that we have a subject, I guess, and the subject is tic-tac-toe. Can I import that? Import tic-tac-toe. Tic-tac-toe player. I hope so. Oh, this is not a class, right? Ah, interesting. Okay, so if this is not a class, I can do it even easier, because then it is just a function that we call, like player. We just have to import it, this guy. Now we can execute it with a board. And the board is, as we have learned, runner, tic-tac-toe, actually this guy. He don't know about these things, so I also get that into the test here. So, is that correct? Your make function from method make. That's all right. Okay, and now we can make self dot assert equal. Yeah, good idea. So we have here the player or current player, and if we put in everything empty, we expect that it is assert equal to and that would be empty, I guess. Or would it throw an error? That's a good question directly. What's wrong here? Variable and function should be lowercase. I am. Current player. Test is upper, split. Okay, basic example. So let's see if I can run that test. Run unit test. Yeah, fantastic. So failure. We received actual expected O. None is. This is the expected. So, okay, we get 0 and 0, and I guess that's why it returns O. But the question is now, is that correct? So let's see what our expectations tell us. So if I check here, we say in the initial game state, X gets the first move. So if everything is empty, X should be the right one. Subsequently, the player alternates with each additional move. Exactly, so it swaps all the time. And I see right now that we have to do that for each row, but these things we do not want to do that like so, I guess. So we have O equals 0, or O count equals 0, and we have X count, which is also 0. And now we say O count plus equals the row count of O, and X count is plus equal to the row count of X. O count is bigger than X count. O count. So first of all, we have to change that slightly, because we have if both of them are empty, so O count and is equal to 0 and X count is equal to 0, we directly return X. And I guess this is AND, or small AND, yeah. And this is an elif. So, and else we alternate. Yeah, but we don't save somewhere which one is running. Cool. So run. None is not X, that's correct. Our test is currently wrong. So what we say, it's empty, but actually it should be X. Fantastic. So now we have our first running test. I'm very happy with that. So first player should be X. The refactoring, go for it. And I guess this is still the same. Cool. Good. So the next unit test that we want to write is, yeah, what happens if X made this move? So second player should be O. So let's assume one of them is X. So now the result should be O. Let's see if our test is running correctly. No tests were found, okay. We rerun that. Still no tests were found. What did I do wrong? Definitely, run. Okay, something I did wrong, I guess. Unit test case from tic-tac-toe. Yeah, let's undo that quickly. So now it is a test, but if I so let's try that again. Now we bring in that again, and I guess we have to start with and test underscore. Yeah, okay. Run. Way better. Okay. So the thing is, we have now one X, but unfortunately, it seems that we return O. So let's see what we did wrong. So the O count is smaller than X. And then of course we don't return X, we return O. And if they are exactly the same, if O and X are, then we return X, I guess. And I think I can make here an OR. O count is equal to X count. And now I can remove that. So let's try that. Both is green, fantastic. So first player is that, second player is that. now let's just get another one. Last but not least, you could say that we test if our third player is again, third player should be again X. That's correct. So good. Okay, with these 3 tests we made it now sure that everything works correctly. That's good. And let's see what we have else. The player is working with that. Next step. The actions function should return a set of all the possible actions that can be taken on a given board. Each action should be represented as a tuple ij, where I corresponds to the row of the move, 0, 1, or 2, and j corresponding to which cell of the row corresponds to the move. Okay. So every action is I and j, and what we define is more or less what I did here. I make that smaller now. Go away, cool. I'm not sure if I can group them. That would be also interesting. Do we have here in the unit test of this class? No, okay. So keep it like that. Up. Can go away. A set of all possible actions that can be taken on a given board. Okay, so how did that work? We have the board again, and we create a new set. Possible actions equals set. Okay, and now we can say possible actions at, right? Yeah, cool. And now we have to identify what is possible. And actually, what we can do is we have to identify every empty part where it exists. So what could be a possibility? We could have a for loop which gets the x in range of the length of do we need that? Yeah, we need that because we need the index where we are at the moment. So what I can do, I can also name them correctly. So this is I, which is inside of the board. So is that correct? I is the row of the move. The row of the move, exactly, and the cell is inside. Okay, so the next thing would be for j in range of length of board I. So what that means is I is the row of the board, while j is equal to the cell in the board or of the row. Okay. So now we go inside of each of the cell elements, and now we have to check, okay, are you empty? And if you are empty, you are a possible move. So that means, first of all, we start our tuple. Or actually, we just create tuples down here, right? So whenever the board I and j together are equal to empty, if so then we have to say possible actions at ij. And if we are done with our loop, we return the possible actions. So, but back to our tests. Can I call that player test and let that run? Yes, I could. So let's see, we call that player test. We have that. Maybe also rename this to player test.py. Get the next part that we call, in our case, it is actions test. So new file actions test.py. Class actions test, we create that. And important it is that we import unit tests. Unit test.case or something. Yeah. Good. Get that inside of here and import unit tests. Dev test actions or possible actions. Actions self. Fantastic. Now we receive from the players. I think I can use the same empty board beforehand. So then we can say possible actions equals to this closely. We remove the current player, of course. And instead of player, we have the actions. What was that? Oh, yeah. Was it not actions? Actions. Import. Yep. Better. And these empty and so on we can also take from the player here. Bring it inside. That's good. And now we can say inside of here self.assert equal. And the possible actions should be a lot here in that case. So possible actions should be a set. A set is, I think, no, this one. And then we have a tuple like I and j. So we would have 0, 0. Reformat file. That's correct. I'm doing that all the time, I guess, but there's not so much to reformat at the moment. So, but we will have multiple of them, I guess. Yep. 1, 2, 3. So still 1 and 2, and then we would have the same procedure again. This looks now a little bit tedious, but this will help us a lot in the long run, because then the testing will always guide us. On the other hand, you could say now, okay, it's just a tutorial, why do we need tests? And I would say, yes, you're right, but yeah, I'm just a big fan of tests. Good, so we have that. And I think that should be exactly the same result. Let's see. Okay, that is fantastic. So all the tests have been running fine. No tests were found. Okay, it seems it was not a good idea to split that up into different files. Let's see if I can edit a configuration here. Python test, Python, PyTest, I guess. In blah blah blah, script, module name, project, tic-tac-toe. No. Script path. Cancel. Can I mark this directory as testing? No, it doesn't seem like. Why can't I do that? Okay, anyhow. Don't lose anything from that. Let's stick with the actions for now. Okay, the first test was successful. That is already a good news, right? So we can copy that. And we can rename that to test possible actions first move. But what would happen if we have already a lot of X's, a lot of O's? O, let's keep that open. X, O, whoops, X. So why is that now yellowish? Duplicated code fragment. Au contraire, I don't think that is true. So now the tuple should be way easier. That should be 1, 1, and the other tuple should be 0, no, 2, 0. So test only 2 options. Green, fantastic. Okay, our code works fine, it seems. XOX, OX, OX, yeah, makes sense. Good, that is also correct. Okay, so we have done that here. That's working already. Initial state is still the same. Result returns the board. Let's read first here. Any cells on the board that do not already have X or O in them. Any return value is acceptable if the terminal board is provided as input. Maybe one extreme case we should also test that I forgot now, and this is if we have the full board used already. I know it's not real useful or finished board. It's not a real useful test, but because in order to have that, we have to finish the game somewhere. As you see now, we have 2 winners. But what I want to test is just if we will receive any turns or any possible value. And let's see, we have this is unequal of a set. Okay, could be. Maybe like this. Okay, yeah. So it seems to be an empty set. Okay. So, next. The result function takes a board and an action as input and should return a new board state. Expected set. I2. Expected. I could try this. No. That's correct? Okay. A set specific equivalent. Set 1, the first set to compare. Set 2, the second. Okay. Good. That. I did that already. Okay. Just wanted to. Okay. No, that's. Cool. Anyway, it works. Cool. Yeah. Result. Takes a board and an action as input and should return a new board state without modifying the original board. The result function takes a board and an action and should return a new board state without modifying the original board. Okay, so we have an immutable function. If action is not a valid action for the board, your program should raise an exception. Okay, that makes sense. So if you try to click another time on an already used tile, and let's start with that maybe. So, oh, how does the action look like? To make IJ on the board. The board and an action as input and should return the new board state without modifying the original. Okay, so the result actually makes the move in that case. So we receive the board again with our row and everything. And we want to make the action on that. So we take a board and in the action, the action is a tuple. Can I access that somehow? have to quickly think. So the action is probably a tuple, right? Can I do something like that? No. We get I and J on the board. Can I do something like that? So that I say I, comma J equals to action. That seems to work. Okay. So now we use the board and say, first of all, we have to check if it is already used. So if board I J is equal to is not equal to empty, then raise an argument or exception. And which exception? I would like to have an argument exception or bad. Python argument exception. Built-in exceptions. What do we have? Base classes, base exception, exception arithmetic, lookup error, assertion error, attribute error, or assignment fails when an object does not support attribute reference, type error, generation exit, import. No, I would say we stick with the assertion error. Something is wrong here. So can we pass something inside? A message or something? No, doesn't seem like that. Could put an exception inside. Assertion error, yeah. Board at this state is already used. Okay, if this is not the case, then we want to return the new state that it could take, right? So without changing the original board. That's also interesting. So we need to, I don't know if that makes automatically a deep copy of the board. Python deep copy list. Deep copy operation on the upgrade. You can use copy deep copy for deep copying a list. Okay, copy.deep copy. Copy board. So this is our new state. And on new state, oh wait, slowly. First we have to identify who's our player. Who is our current player? And for that we already have the function player where we pass in the board. And this gives us a current player. Now we deep copy the board, and now what we can do is we say on the new state where I and J comes together, we set the current player. So, okay, and then at the end we return the new state. Identify who the player is. We make a deep copy immutable board. We set our player. And at the end we return the state. Well, let's see if this works. It looks a bit weird, but result test.py. Yeah, let's just copy that one. So let's call it result test. Okay, I remove these two tests for now, and this one is now the result. The first thing is a board, and the second thing is the action. And the action is actually the board again, but with one, no, it's just a tuple, right, with I and j. So let's say we want to put 1, 1. Okay, so x is on the move, and now the result that we expect is actually this. So we expect that this happens again, and this part should be x. And this is what we expect from that here. So expected result. No, result, and this is the expectation. So check. Fair enough. And let's see if this is correct by validating with an O. It's actually correct. Who would have guessed that? Good. So let's just try the same thing once more. And let's change the name of that. Make move on, test make move on, or make first move. So here test make third move, or better the fourth. So you are X, you are O, X, and we want to change 0.2, and the expected result is actually the same thing, but with a change in that part here, which should be O now. So test, oh, there's a mistake. So 0 to, of course, this one should change. Oh, and this is empty. Yeah, better. Okay, and now the last thing that we have to try is if we try to access one that makes the exception, right? So test exception on invalid field. So we pass inside this part and we try to override 0, 0. And now we want to self exception or catch. Raises regex? No. Raises expected expection. So, and I think we have to pass in something. So let's see, how does that work? Python exception test or unit test. Assert raises and then some cool exception from my function. Okay. So in our case, this is the function that we want to call. And the cool exception would be the argument exception that we, no, the assert exception. Assert error? Let me check. How did... Assertion error. Yeah, okay. The assertion error. Good. Now let's try that. That didn't work. Failure traceback. Oh, okay, we have to pass in the string, I guess. Oops. So. Oh, wait, this tuple is too much, I guess. Can remove that. What is the problem at the moment? Let's get that back quickly. Just do it like that and remove here the tuple at the end. Is that too much? parameter action unfilled. Ah, no, we need the action, of course. Yep. So what's the problem? Failure traceback raises assertion error, which is perfect. Is he not happy enough with that one? Note that to pass arguments to my func, you need to add them to the... You have to wrap context in string, otherwise you will get type error. Assert this is broken in string context exception. Wait, maybe I have to do it like that, so we give in the function and after that we pass in the arguments like so. That could be, so we have to remove this, and this is just the function that we want to call. Like so, maybe? Aha! Alright. Good. Okay, so what we did is now we raised the error. We have the assertion error that we throw ourselves. We made then tic-tac-toe result. That is the function that we want to call, this guy. And inside of here, we pass in the arguments after that. So where did I find that? That was this part down here. We don't actually run the method. We just give it inside of the method. Okay, good. But our tests are running. That's good. And with that, we have our result done. So now back to our tasks. The result is done. Importantly, the original board should be left unmodified. Max will ultimately require considering many different board states during its computation. This means that simply updating a cell in board itself is not a correct implementation of the result function. You will likely want to make a deep copy of the board if you have done that. So the winner function, maybe could I write a test for the old board that it stays unmodified? I could, but let's be honest, that should be okay. On the other hand, maybe just one test. I think that should be easy. So def check board stays unmodified. So, and the idea is that we do actually the same thing like here. So we get the result, but here we have the board. And what I want to do is creating a variable for that board. And important for us is that the board don't change. So we take all of that. And what we say is board is equal to whatever here is. So we don't really need the result, but we have to execute the method. And here the naming typo, yeah, we should make that correct. So, and of course not check, we have tests. So let's go and run the class. Yeah. Okay, so if we wouldn't not have made the deep copy that we did here, and we would just say we take the board, I think we would change the board itself. So let's take it like that. And now you see that the torch say unmodified will break. Good. Done. So the winner board returns the winner of the game if there is one. Did we forget here anything? No, that's good. So the winner of the game if there is one. Okay, so actually we just have to identify... how would we do that? We will have to identify if it's diagonal and so on and so forth, and we have to check that. What I want to do quickly is writing myself down how it would look like. So like this would be a winner, then we would have something like this would be a winner, then we will have this nothing, 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 x, nothing, 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 x. This would be nothing, 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 or something else. So I get the state, the current, and now I have to identify if there is a winner. So I could get every row, and if I find in one row 3 X or 3 O's, the corresponding one has 1. That would be the first win permission, right? So let's start with that. So we go for each row inside of the board. And if we count now, let me think. So count. How was that with the count? I did that already at the beginning. Row.count, yeah, okay. So row.count, and now we can count the x's. And we can count again the O's. Count x equals 0. Count O equals 0. For each row in board. Okay, and then I can say something like if count x equals to 3 or count O equals to 3. Okay, then I have to return. No, wait, then I can do both. 3, return x, and if count O is 3, we return O. He can remove. Okay, good. And else, if none of them is true, then we have to set the count x again to 0 and the count O again to 0, so that we check every row for that. Do I actually have to do that? What I could do is just define that per each. So count x equals, and this is count O equals. And then we don't have to do that. And I think that would be check each row for a winner. So I think that was the easiest part, right? So now we know that every row has a winner or not. So how do we do it for the diagonals? So we have, let's draw again a picture. Why is it working for that here and not for me? Okay, anyway, so let's say we have here O, nothing, and we have here O, X, and nothing, and we have nothing, nothing, and X. So now we have a winner, right, for X. How can we do that? We go for this diagonal win, we have to have the middle part. So that is important. So there is no winner for that, but so this is only if we have X, 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 right? Well, maybe should take something. So this is for the row, right? And then what happens if we want to have the same thing for check for, how do you call that? The column. So the column is also interesting, right? Because how do we do that? We would have to use the column and check if the... I ask myself if there is a good and easy solution or if I make it too complicated. But what we could do is we go for each part of the row. So let me think. We have a row and we have a column. So what we could do is, again, this I and J thing in board. No, in range of length of board. And now we can say this is the row, right? The problem with that is that I would go through each row and then I have to check everything and have to save it somehow in between. That could work, but I don't know if this is elegant. Column check. I have an idea. Okay, so now we have this. Here we have to check all three levels, right? We have a row. And what I could do instead of doing this, I know that the length is always 3. I just hope that this tic-tac-toe game does not increase by size or something. But if it is only 3, then what I could do is make it fixed. So that I say we have the board and we have something that goes to 3. So 1, 2, 3. 1, 2. So, and this is the rows. But what stays the same is actually this. Right? So, and now I could make the check against that. So something like, that's pretty much, wait, but what I could do is like giving the range. So we have in range of, I don't know, 3, or do I have to take 2? Not sure if the range is starting from the, is the range starting from 0 or does it start from 3? I can define that, so let's do that. So start 0 and the stop will be 2, sorry. Okay, so this will be the first parameter. So we can take our board, I, and what do I want to check? If there is a winner. I need that a second time, which is our J, but wait, cannot be too hard. So let's think. We have the board. We know now that we are in the first column and we check for X, X, and X. So I know that I already solved that once, so now I just have to identify how. Okay, what I can do is I can count, right? Let's make it completely easy. So we have a count of X and we say it's 0. And if the board on this part is equal to X, then we increase our count X by 1. Something tells me that doesn't work. Unresolved plus. So now we have the first column check. So, and then we could say something like if it is free, or we could also say board. Wait, we can remove that, take that a second time, and we say count O plus equals 1. O. So, kind of this. I call that now column count. And also this one I call column count. X, and this is column count O. So, and after we have calculated that for each, I have to, okay, now I got it. So now I just go through the different columns, but we need also to go through all the different. I need a second loop, of course. So we have here J, and we have to put that one level lower. And I guess what we need is now, let me think. So we have to turn that around. So J is second. And this column counts is for each column. So now we are coming somewhere. So we increase that by the integer by 1. So, and after we have finished this for loop here, then we can say if column count, oh, I don't need a column count X equals to 3. Can it be 3? 1, 2, 3, yeah, should be. Then return X. Else, if we have the column count O, which could be 3, then we return O. So, and with that, we have checked the different columns. So we have checked the rows. By the way, let's change that to O's. I think that looks a bit more U-friendly. So, and the columns would be something like, let's make 3 of them, would be like O, O, and O, right? So no matter if I'm in the first one or in the second one, that should be the solution for that. And because I'm unsure at the moment, before I finish off now the rest, I want to start writing tests for that because it seems a bit more complicated. So winner.test, whoops, test.py, take again the whole thing, bring it over, remove some of the tests that we have already done, call that the winner test, and let test column winner, or let's start with the test of the row winner because it's the easiest one, I think. So we have the method winner, and here we have X, X, and X. And this result should be X. Oh, let's try. That works, that's perfect. So let's try the same thing for O. Careful. So Ah. And by the way, at the end, if there is no winner, then we have to return null or something, right? That's important. So then test O. So we don't take that. We have here again empty, empty, and last but not least empty. And we return the last one as O's. Okay. And that didn't work. Ah, yeah, sure, because O wins, not X. Fantastic. Good, and then we can try to test our columns. Test column winner. So we have here X, X, and another X. So, of course, that's not O. It would be X. No, we receive an error. No keyword argument. Range takes no keyword argument. Not sure what that means, but let's do it like that. Okay, so that is still not correct. We have free X, and X should win the game. So we don't have a winner here, that's for sure. And here we have a J from the range of 2. And we have I from the range of 2. Let's do it quickly for free, just that this is the problem. Okay. Okay, that was quite easy because the range was too small. Okay, so let's see if this works also for, this is X. And let's see if we can do the same thing for the winner of O. So we say here's O, but what we actually want to see if this and this leads also to a win. This should be O this time. But it seems we receive none. Okay, so this time we have a mistake somewhere. So this is wrong, but the last one should be correct. So why does that not count as free? So this is false and this is true. So what we could do is making a breakpoint here quickly. And if I run this in debug mode, we jump here inside and now we can take a look into the whole thing. So count O and count X is not important. It's the column counts. And what do we get? We have the third, the third, and the third. Okay. So the first row that we check has X, O, O, and we check the board with Y and so if I, no, that's not the correct one. Expression, evaluation, that one, that is option F8. Okay. So if I run that, we see this is O. That looks correct, right? I and J is 0, 0. Yeah, okay. We got that. Run further. So now we have I1 and J0. That means from the row, no, not from the row, from the board, we go to I, to the first row, to this one, and check the J, so to the first cell, which is an X. So that shouldn't be... I see right now that we only check for X. What is that? No, this is wrong here. I think that was the only mistake. Ah, very good. Good that we write tests. I'm very happy with that. Perfect. Good. Okay. So with that, we have identified one bug. Fantastic. Very happy. Now this is working too. So, and the last one that could win the game is if we have the center. One of the players has the center, and then we could work diagonally. That would mean what is winning solutions is let's us create the tuples for it. So that would be 0, 0. That would be 1, 1 and 2, 2. Oh, I see a pattern. And I guess this would be 2, 2. No. 0, 2. 1, 1. And I guess the 2, 0. This, and there are not more, right? So I think we could identify these. How can we do that? We would have to... we could do it very hard-coded, I guess. That would be something like board 0, 0, 0, 0. Let me see. If board 0, 0 equals x and... have some water. Thank you, Deepak. Don't have so much water anymore, but I think the stream will be, or we will be finished soon. So I hope the best that I will survive it till the end. So then we have 1, 1, of course, because both of them has to be 1, 1. And board 2, 2. No, wait. 2, 2 equals to x would lead to return x. Right? And this here is the first solution. Or, and now we have to turn that around. That would be 0, 2, 1, 1 and 2, 0. Right? Okay. And obviously this here can be done more precious. So let's see if we can create a method out of it. When executing flow is interrupted. Okay. Why is it interrupted? Okay, let's see. Calculate get diagonal winner. And what I want to give him inside is just X or O. So the current player, actually. No, I give it a board inside. Wait. No, I have to do it anyway for both. If I do it like that. Could I do something like that for player? And then say something like in list of X or O. And then we do this here. And instead of playing X or thing, we say player. Is it even correct? Let's think. 0, 0 would be on the top left corner, 1, 1 is in the center, and 2, 2 is on the bottom right. Yeah, I think that's correct. Okay, so what is here? Rename element. Okay, you don't like to have player, so Shift F6. I don't know. X or O. Current player, or don't know, something like that. Okay, and this is the diagonal range. So find diagonal winner. Check for column. This is the find column winner. Good. And now let's check our test again. So if we have that test diagonal winner x first. So we have here x, and here x, and it's just important that nowhere else is a winning. So we have to make that sure. Bum bum bum, looks good. And let's run the tests. And there is a problem at the moment because we tell that it would win by O, but actually the X is the winner. Try it again. Green, that looks good. Let's do it on the opposite side. So let's say this would be O. We would have here X and we would have here X. So like this. Diagonal winner. How do you call it? A mirror. Good, works also. Let's create the same two tests again for O. Let's assume that we have O here, and O here. Let's change some of these to X, just to don't confuse everyone. Something like that. Get the same and without mirror. O, O, O. Getting here some X's in between and some empty. Whoop, and that should do the trick. Of course, not X wins the game, it's O who wins the game. And we are good. Great. So, if player has won the game, your function should return X. Oh, okay. One can win the game with 3 or their moves in horizontal, vertical, and diagonally. You may assume that there will be at most one winner. That is, no board will ever have both players with 3 in a row. Since that would be an invalid board state. Okay, I understand. If there is no winner of the game, either because the game is progress or because it ended in a tie, this function should return none. Okay, also something that I forgot. So that means if we run now, let's make some test-driven development and no winner. So let's see, how can we do no winner? I have here no empty. So this is no winner and test no winner. And now this one should return none. Run. Okay, it seems that it automatically, if none of this runs, then we automatically return none. Okay, can live with that, I guess. Fancy. Okay. The terminal function should accept the board as input and return a Boolean value indicated whether the game is over. If the game is over, either because someone has won the game or because all cells have been filled without anyone winning, the function should return true. Otherwise, the function should return false if the game is still in progress. That shouldn't be too hard, I guess, because we received the board. And actually we could just count the empties, right? If there are still empties left and there is no winner, then we return, okay. So yeah, we count empty equals 0. We have our for loop again of the rows in board. We say count empty plus equals row dot count empty. Exactly. So, and if the count empty unequal 0 and what was winner? Just winner of the board. unequal, if the count is unequal empty and the winner of the board is none, then return, what should we return if false? Okay. And then else return true. Should be correct, I guess. I think what I want to do is, because of performance reasons, I don't think that it should be an issue, but still we could do something like that. If we check in the beginning that the winner is none, we could return false. If we have a, no, this is not true, but if it is X or O, then we return true. We don't even have to do that counting of anything. So, and then we are with that anyway sure. So this count is the only thing that we care about. So I guess this makes sense. So the last test that we have to write is the terminal .py, getting the test again. Yep. So, and here inside we want to test no empty fields, or yeah, test no empty fields. So that means we fill everything up without a winner. So let's see if I can do that. Losing on purpose, not my easiest task. So that would be an O, that would be an X, or could be an X, and that would be an O. Looks good. And here that would be, the result would be true. Zuck, run. Re-return none. Okay, we get the board. No winner, so we have, no, here. We return none. Because we called the wrong method. That would be terminal. Good. Okay, that worked already. So the next step would be up winner. If we have a winner, like so. Test winner. Then the game would be empty too. That's working, okay. And let's do the winner and add some empty fields here, just to make sure that this is not the reason why we have a winner. Yeah, that's good. Then we have test the false case, right? So we have still values and no one have one. So we still are in progress. So that would mean we have here an empty. That is wrong, right? Nobody has one and we have an empty field, so that should be false. Okay, we have a mistake. So no winner, no winner, no winner, no winner. Oh, tie. I think tie I have done up here, right? There's no empty field and nobody can move. But did I make here a mistake somewhere? No. That seems that this is somewhere wrong. So we have, if the winner board is X or O, we return true. The question is now, do we... the good thing is we can run this one in debug mode. So, and now let's see what we get. The winner is true. Huh? The winner of board. Did I somehow make a mistake and somehow added a winner? No. Uh-oh, I have the feeling we have a bug somewhere. So let's see if I do it like so. Up. We receive none. Is X or O? And now he wants to say me that this here is true. Evaluate expression. Ah, probably I have to do something like that. Aha, alright. Yeah, you should know the language, right? Then everything is easier. Up. Retry. Aha, green. Fantastic. Good. But we've discovered another bug. Fantastic. Without even to do too much work with it. So testing is a fantastic thing. Highly recommended to everyone. So terminal is done. Utility. Okay, now the difficult stuff starts, I guess. The utility function should accept a terminal board as input, and the utility of the board. If X has won the game, the utility is 1. If O has won the game, the utility is -1. If the game has ended in a tie, the utility is 0. You may assume utility will only be called on a board if terminal board is true. On a board, if terminal board is true, what do I get? I get the board only. So I have to understand who won the game, right? So winner of the board. Yeah, winning player. And now what do I have to do is if winning player equals to or is X, then return 1, else or elif winning player is O, return -1, and else return 0. Sounds about right, or shouldn't be too difficult. So if we call this method again, and what I will do now is I will just add it to the terminal test because I'm too lazy to create all these different files. So dev test utility X wins self. So with that we get all these parts. And here, let's say we have X1, then this should be 1. Then we have O wins. O and O. Then we have -1 and a tie or a draw. Draw would be nobody wins, like so, and this would be 0. Okay, let's check that out. Oop, run. No. Expected. Did I forgot to change from terminal to what was the method? Utility. Utility and utility. Yep, that worked. Bug hunting equals testing, indeed. So let's fight these bugs in our code. Okay, but utility seems also to be fine. The min-max function should take a board as input and return the optimal move for the player to move on that board. The move returned should be the optimal action ij, that is one of the allowed actions on the board. If multiple moves are equally optimal, any of those moves is acceptable. If the board is a terminal board, the min-max function should return none. If the board is a terminal board, the min-max should be returning none. Once all functions are implemented correctly, you should be able to run the runner and play against your AI. And since tic-tac-toe is a tie given optimal play by both sides, you should never be able to beat the AI. Though if you don't play optimally as well, it may beat you. Okay. If you like to test your functions in a different Python file, you can import them with the lines from tic-tac-toe, import initial state. To add additional helper functions to tic-tac-toe py, provided that their name do not collide with the function, makes sense, but may make your run more efficient. Alpha beta pruning. Okay. So I think that function will take another time. The move return should be optimal action. So that brings me into here again, just to read once more how the min-max actually worked. By alpha beta pruning, by the way, is meant that you don't search further if there is no option that could be lower for that person. So with that, you reduce performance usage. V is infinity for action and actions. V min, V max value, result state action, return V. Given a state S, max picks action A and actions S that produces highest value of min value result. As a min picks action A in actions that produces smallest value of max value. Okay, so actually we would write these two things. That's Okay, now we're coming to the interesting part actually. So let's see. So we have the def. Let's write the function max value state. The state is the board. So then we have if terminal. I think we have that. We can pass in the board. Then we get return of the utility of the board. Okay, so we get if the terminal state. So if we are done, then we just return the utility. Else we have V. What was V again? V was a deterministic from something, I guess. V was the value. So the first value that we set is minus infinity for the max value. So every move that we do is higher valued than the one that we do right now. So how can we say infinity? V equals, is there an infinity? Infinity minus 9. Good question. Let's see if we have one. Python infinity. Import math.inf. Okay, so math.inf. If we say negative, we do it. All right. So what is the next step? Then we have for action in actions. Okay, for action in actions of this board. We have to discover the value of that by getting the max value. So I think math has the same value, right? Math max, I guess. No? Max? Ah, just max. Okay. Max of V or the min value. Min value is also a function that we will write in a second. with the result of the board and the corresponding action that we receive. Okay, you see I get a bit faster. That is just because I'm getting tired, I guess. We would have to once more go about every step here, but I think I understand. So the result is the state again. So that would be a board. And actually we would do exactly the same thing. The only difference is that this one is now with a plus infinity. Action and actions, we have the board, we get the result. And this here is, I think, the min value here. Min of the max value. So what we do is we go through all the actions that the max value could do that are currently on the board and check what the value is for the max player. So if we want to get the minimal value, we check the max values options on the board with the results and check if our value or the value of the player is lower. On the other hand, on the max value, we do exactly the opposite. So and the minimax, so how does the minimax work now in that case? Min value, max value. Max picks an action A and action highest value for the min value. What is the case? Returns the optimal action for the current player on the board. So first we have to identify who is the current player. That would be player of the board. Current player equals. And now we want to find the optimal thing. So if the current player is equal to X or is X, then we want to get the max value of the board, right? And else, or elif, let's make it more, the current player is O, we want to get the min value of the board. And we want to return both, I guess. Let's see if this is correct. The move returned should be optimal action that is one of the allowed. Oh, we don't. Oh, what do we get here? We don't return anything here. So we only get the value of this action. Wait a second, my head is spinning a bit. Let me think about it. So if I'm taking a look here, we return the value for V, but the problem is I don't want to return V because V is the value, or what I actually want is the action that is corresponding to V. What I could do is I want to have the highest valued action, right? So, and this is at the beginning nothing. None. And then if whenever V is so if this method is larger than V, then the highest valued action is the action. Then we do that, we go over everything and we return the action. No, the highest valued action. So now we have the F, we have done this. I think that should be the trick. And the same thing we have to do. Can we? No, I don't think so. All right. Oh, wait. Min value. The highest of V, so is this higher or this higher? And we always take the highest value. This is stupid what I do here. That makes no sense. So let me see if this is that. We have to remove that, of course. So if the min value is larger, wait. The value only determines the value of the current board. So with that I receive the value, but I get the value of max. So I will always distinguish if a V is larger or the min value. So and if I know that V is larger than the min value, V is smaller as this. We don't need parentheses here, so then we return, no, then the highest valued action is the action. So I think we had that before. Highest valued action is the action, is none at the beginning. Okay, then this, and at the end we say highest value action is returning. Hey Stefan, nice to see you. Hope you are well. So, what a crazy thing to see here. Huh. So you missed quite a lot. We made AIs everywhere. We are perfectly, or I am perfectly fine. Had a perfect start in the new year, and I hope you too. So we have that, and we need the action. We don't need the max value. We actually don't care, right? So if I see the mission again, the move return should be optimal to action. So we search the action. That is now actionable board. If multiple moves are equally optimal, any of the moves is acceptable. Okay, so we just take the highest one. Okay, and this means if we have something like that here, we would have here exactly the opposite. So we would take the action, it would still be the highest valued one. That comes one below. And now we have to change that, of course, to the max value. Ah, this is the problem. I cannot do that, because they are depending on each other that they receive a value and not the action. Ah, damn it. I cannot do that easily. Yeah, don't remove that. Return V, get this stuff, and this cannot work. So how do I get the action? So the max value depends on the min value, and this one returns also V, right? Yeah, I can understand that. As I said, when I was fighting with myself the last 3 or 4 days if I shouldn't make a live stream somehow, and I was always nah, tomorrow is also a day, and tried to push it in front of me. So yesterday we made a lot of progress in the Discord channel. Thanks to Deepak and Minu, we had there a great session together where we worked a bit on that. And yeah, finally today I was fighting and solved myself that I want to do that. So we don't want to return this max value. We want to get the action for that. What I could do is, instead of, we have V. And what I could do is I don't return only that. This is Python. It looks a bit weird, but it's actually pretty close to whatever we know. What I could do is that I don't only return V, but also the action, or the highest valued action. So we have the highest valued action down here, and none. And then down here we say again this if thing that we had seconds ago. Let me check if I find that in the local history. Bop. For actions, blah blah blah. No. Okay, then back to the drawing board. We get the value. Let's check. We have the min value that we get from this. But because we return this time this part here, how can we access that? So min value and action would be this. Here's this one missing. Okay, and then this part here would be not this, it would be min, lowest value. So, and with that I will get this part that I need. And if I, and maybe I should lowest action maybe. So with that I get this, I can distinguish that somehow. And down here we can use that. And here we still would get that. So, and if the lowest value is larger than V, then we have the highest valued action, the action. And this lowest action, and this would be lowest value. Lowest value. And actually, yeah. So, and important it would be that we do the same thing for down here. So we make this map, a set of V and highest valued action. So, and what we would do is actually we would do exactly the same thing again. I don't want to copy that over, too much effort, but get the stuff down. So receiving this from the min value, which we would do here. In that case, it would be max value. We receive the lowest, in this case, the highest value and the highest action. That is that. That would be this guy. Kind of this. So we get the value back and we can return that. Math infinite, blah, blah, blah. This works. And I think I have to change this here. Where's the if statement? I didn't implement that yet. So we would need that. And now if the highest value is smaller than v, v is very big. So the highest value can just be smaller than v, right? Then the highest valued action is the current action. Okay. Now I'm really curious what happens here. So let's see. New file, minimax test.py. Let's get our testings up. Remove everything that we don't need. So I think we can remove this and test min value. Okay, so how do we get that? Tic-tac-toe, we have the max value and the min value with a board. So import that, and here we want to give a board inside. Let's copy one of these. For example, that one. Or better, one that is not terminated, like this one here. Good. Minimax test, go inside. And result equals this. None of the actions has any benefit, so I would guess that the first one would be returned, right? So the possible actions up result would be we get the value back. Actually I don't know what the value will be. So let's try that with 0 and would get 0, 0. Let's see what's coming back. Error. Okay, stuff is failing. Cannot unpack non-iterable int object. Int object? Of course we do Flutter streams, but at the moment I'm working on the certificate from CS50, and this is an AI certificate, and my idea is to learn first the fundamentals to understand how to make the searches and then create Flutter projects on top of that. So for example, if we would like to create a Flutter or to identify how the A* search works, and I know now how it works and I can implement that, then I want to create a Flutter app that maybe works like this one, that you can play against an AI that is driven by or you can visualize it with Flutter, and in the background maybe there's Python or something like that. I don't have a full plan of that, but at the moment there are a lot of things that I would like to learn from the AI. So this is just a part of it. And because, yeah, I have to start somewhere, I thought I do it in a live stream. So, but at the end you can take everything from that, most likely also back to Flutter at the end. This is at least my hope. So let's see. It seems that it cannot deconstruct this part, I guess. Yeah, so he drives here crazy. The max value. So if I let this test run once more with the debug on, let's see where we come to. Assertion failed, assertion failed. Okay, so this is not a winner that I implemented here. I don't even come to that point. Yeah, sure, because it crashes at that part. So let's debug that once more. Yeah. Okay. So we have tuple 2, 1, 2. We have only one action Does it make sense? Actions of the board. Let's make evaluation. No, we have a lot of actions that are possible. And now we call min value with the result of the board of action. So what do we receive here? Expression. Cannot unpack non-literal objects. I'm not sure what I read here. What would we get from this? Okay, this is the result we get. Okay. So that means it jumps into the value here, I guess. Yeah. So if terminal board, that is not the case. V is infinity, highest value action we don't have. So, and this is calling... this calls now the same thing, but with the board, with the full board, but with a different action. And this is calling that up there again. And then it crashed somewhere. Maybe I'm doing that also way too complicated. Let's just return to what we had before. Let's have a look. Yes, Stefan, I can imagine, especially if you just jump right in the between into it. It's very difficult to following up, I guess. Stop and rerun. All right, so the value stays 0. Sounds valuable. Use scroll controller. Flutter hooks, debug, keep scroll offset. Ah, nice. Okay. Bloody hooks. Yeah, true. How can that be too hard at the moment? I don't really get that. Expected utility of the game from a given function. See you, Stefan. Enjoy the rest of your day. Okay, I'm still fighting with that min value, max value. we receive with that, of course, the minimal value. That makes sense. So we need both of them, because if we call this guy, but he understands the action with the highest possible value, right? Min value board action. So with that, we only give the maximum of the value inside. How do I get the action that is most valuable without destroying the whole work that is going on here? So let's print an action here quickly and make a debug. I just want to see something. Okay. Aha. What's going on? Does it ever finish? Holy rip. So here you can see how much stuff we're running through until it breaks. Okay. So it goes through all the possible options. And it returns null, zero. Makes sense. So that means after every step that could possibly go, we always have a draw, right? Between the best player and the worst player. Could I not just make like an object? Now let me see if I can just create an object. That could be class result. Up, and this one has a value. That's and I don't know, an int maybe. So, and what we also have is we have an action. And the action is a tuple, like int. Don't know if this works, but something like that. So what I would like to have is if so if if v is smaller, larger than the max of this, then we create a new result with, I think I need to make there an init. So how do I make a constructor in Python? Constructor Python 3.9. Blah blah blah, a lot of text. Do local, do non-local. Okay, but I mean, actually, this is anyway what I receive from it, right? Ah, what a problem. I cannot identify it. Unequal. What I could do then is I don't want to return, right? It should go further. We still need the highest valued action. None at that point. And we have to return it that way. It makes sense. So the highest valued action equals to action. So then we set V, and at the end we have to return V and the highest valued action. And V, how can we see that? So this is min value? No. But we use the min value a lot. So rather than doing this, we create a method, a variable for that. Value. This is yellow. Local variable might be referenced before assignment. Okay, that would be value and action. Value. I think this is value. Low value. So now I'm doing exactly the same thing like before, I guess, but let me try that. That is the lowest possible action. Is still none. And if, and I think I can copy the whole thing again. Yep. This is min of V, and this will be that part here. We create also for this a variable. Okay, this will be lowest value and lowest action. Lowest value. We return V and lowest possible action. So we failed this time quite early. Cannot unpack non-iterable. Really curious what this error says. 0, 0. Ah, maybe I shouldn't do this, just this. Okay. And still error, cannot unpack. He cannot unpack that. Why not? He gets an action. IJ in items index. Python is expecting that item is an iterable of iterables, which can be unpacked into the variables I and j. Python return two values. using a tuple. We have a function, we return a string and x. String and x is the function, assigning return tuple. Wait. Up. So this is now more problem that I'm not this Python. This good in Python rather than anything else. Lowest value, lowest action from max value. We return these two things. Where do we crash actually? So if I'm looking at the result, min-max test and debug. So if I call this evaluate expression, cannot unpack. Something in Discord? Nope. Oh. Oh, does it? Okay. That's really sad to hear, actually. Sorry for that, Deepak. I don't know actually what is the reason for that. Probably my internet connection, I could imagine. But I really don't get that one here. So I have the max value and I receive from that a tuple. And he cannot identify these two things. So if I make this expression here, I cannot get this literal. Unpack non-iterable int object. Non-iterable int object. Can I tell the compiler somehow that this is an integer and an action, like another tuple? Something like that. Okay, let's do it like the first part here. They create a test class and then put that stuff inside. So this was the other idea that I had, that we create a result class with the in itself. We have self string, in our case it's value, and this is 0 at the moment, and an action which is also nothing. So this result guy, not important for this here, but here we have the function which returns a test. So this returns our result with v and highest valued action. Is that still wrong? Definition of self? No, yeah. Value and action. And this is value and action. Oops. Good. So now we have that object. The same thing we do here. Good. And now we return here, or we receive here a result. Is that correct? Okay, and then we have result dot value, and here we have result dot value, and this is complaining at global statement. What is the problem? Local variable result might be referenced before. Okay, that is something else. Then call it max result. So and so. Okay, good. And up here we do the same thing. We return low result value. Also here, low result value. Good. And this is the highest evaluated. And here we don't return the max value. On the other hand, it's just our test that should run here, right? And hey Machtab, nice that you found the way to Twitch. The int object has no attribute value. Up here we are terminal. Ah, no way. Why should we be terminal? We have a bug in terminal. That is the problem. No way. Oh my goodness. What? Test empty, not terminated. Ah, no, this is different. This is different. Now I get it. This is not the case. So if I run that, this is not the problem. We run all the time inside of that. So if I go to terminal and give the board inside, then this should be true if I'm right. So let's try that. No, it's false, exactly. It should be playable. Good, no, it's not that. The thing is, we run one time completely through the tree until the game is finished. We jump here inside and we get the utility. And the utility, what is the utility actually? Utility is who won the game. So we receive 1, -1, or 0. So the idea is not to get we have to make result of v, which is the utility. How do I do that now? So it would be result of the utility without an action. And none. Probably. Because what the AI does is it finishes the complete game until we are coming back to that. And this is maybe the solution for my problem with the test here. Let's run that. Okay, of course now we have a very large playable game, so it takes time. But we get an error. What do we get? We get a result. Max. So what we get is a result object with something inside. So, and this is not completely true. Okay, I get it. So this means we don't get something like this. This is untrue. Can remove that. Probably. So, and also here we don't get that. So, and here in our min-max test we have the result, which receives an action and a value. So the value should be, I don't know, 1, no, 0 actually. And what I want to do too is I would like to print the result.action. So let's run that. Please be useful. Ha! Do we get it? So yeah, the action would be 1-1. So the center would be the most valuable possible way, I guess. Okay, so we can do that, and this will be the action, which gives us a tuple of 1-1. Then we can remove that. I guess if I do the same thing for the max value, we will get exactly the same result. So if I get that with the max value, I somehow expect that it is the same result. So it also 1-1, the result value should be 0. Crash. And why? Oh, really? For the max? Oh. Oh, what is it? Expected 1-0. Okay, that is the first, but it's still 0, or? Yeah. Interesting. Okay, so the Okay, so both of them are true, but I'm not completely convinced that they are right. But we will see that in a second. So if this is now done and we have the tic-tac-toe, this is now all done. And these things should return now not the value, they should return the best way. So this here will return us a solution, right? Dot action. So this is what the min-max should do. Okay, so let's see what we have here. The min-max should return none. The min-max function should return none, yeah. For all functions that accept the board, blah blah blah. Hints, if you'd like to test different Python file, nope. So, and we could make it more efficiently, but at the moment I'm pretty happy with it. So how can we start up? I think we have the runner py. And with that we have a main somewhere. Yeah, so what I can do is go into the terminal and say Python free and then runner py. So play as x. Okay, let's play not optimal. Woohoo! My first AI that runs in a tic-tac-toe game. How good is that, please? I'm completely impressed. Super cool. Really cool. I'm really happy with that solution. Okay, it took me a while and I'm sorry for that. Maybe I was just standing on the... I don't know how you told that in English, but yeah, I had there some issues. Okay, maybe for the next time I will also take a look into the alpha beta pruning. But this will be not today, I guess. But that is pretty amazing. So visit this link to log in into GitHub account and click authorize CS50, blah, blah, blah. So let's do the last part and commit the whole thing. Verifying, go, 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 preparing, submission cancelled, okay. What is this venv? Why is it trying to files that will be submitted? Keep in mind the course policy submission. I think I have to create a git ignore into the whole thing. Dot git ignore. And then we want to vnf should be excluded. Keep it in the gig, yeah. Not that good, but at the end the stuff is inside. I think I'm pretty happy with that. So we have this is updated. We have created some tests for it. Let's hope that they are good enough for a good resolution. So let's get the form and let's see what we have here. So naming, blah, 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 GitHub, MD Weber. We are in Germany. Yes, there is code. Does your code implement every feature? I hope so. Comments, if any. That was an excellent, an excellent exercise. I cannot write exercise. Work. Experience. Thank you. Submit. Go for it. Cool. And now let's wait till we get submitted. And in the meantime, I can work on the next parts. But I really learned a lot today, and especially again, you should be always considering your code as failure. I had a lot of fun to write some unit tests with it. I'll get rid of all that. Okay, as I said, check out the CS50 degree. I'm really impressed how they solved all that stuff, and it makes a lot of fun with edX to work on that. And I'm really looking forward to do more on the AI front so that we can create fantastic UIs with help or with the ideas of AI in the background. If you have some ideas or what we want to do next, I would be very happy if you tell me as fast as possible. Please join the Discord server underneath, and yeah, debug. We will see us soon. Macht hab. I see you in a second, and see you later. Bye.